So this is my second video to go through the 2016 Mathematics Exam 2, Section A, multi-choice questions. Right, so let's have a look at the first question. The linear function f is restricted on a domain D, and it's 5 minus x. The range is minus 4 to 5. So we would like to work out the domain D. Well, because the linear function is strictly increasing or decreasing, we might want to say, okay, solve minus 4 less than or equal to 5 minus x less than 5, comma x. So you'll be able to get, let's say, 0 to 9, okay? Option A. A graphical representation is if you see, okay, this is, let's say, 5, 0, 5, and this is 5, 0. When you get a y value equals to 5, okay, it may well be here as an open circle. And if y is minus 4, for example, you could chuck in, let's say, a minus 4 and equate to this function. And you'll be able to get, for example, this is a 9, comma, minus 4. So that's this section, okay? Okay, next question is a circular function question. The period is 2 pi divided by pi over 2, and that is a 4, okay? The range here equals to c minus a, c plus a. And that will give you, for example, c is 1, take 2, 1 plus 2. Notice that the amplitude is 2. So you get, for example, minus 1, 2, 3. Option B is the correct answer. Okay. All right, let's move on. Part of the graph y equals to f of x of the polynomial f is shown below. We would like to get the derivative less than 0. So it's before the first turning point and after the next turning point x value, okay? We would like to have negative gradient. Therefore, it's from minus infinity to minus 2 and 1/3 to infinity. Option C. Question for the average rate of change of the function with this root between 0 and 3 is given by an expression. So you might want to use, let's say, f of x is assigned to 3x squared minus 2 square root of x plus 1. And type out a fraction, f of 3, take away f of 0 divided by 3 minus 0. So you get a 25 over 3. Option D. Notice that there is a shortcut. It's called AVGRC, average rate of change. F of x from x equals to 0, 3 minus 0. If you start from 1, then you take a 3 minus 1 here, like an interval length or step size. So it's still 25 over 3, okay? Yep, let's move on and look at the other questions. If you take a look at the next few questions, well, as you can see, the multi-choices are set like in an increasing level of complexity. So question 5 is not an awfully challenging question. It gives you a domain 3 to infinity and a g of x is root 2x minus 6. And you would like to find the inverse function. So what I will do is I'll solve x equals to square root of 2g minus 6, comma g, or 2y minus 6. And you'll be able to get this inverse function. G inverse is x squared on 2 plus 3, and x is greater than or equal to 0. Just notice that you can combine these two terms into one. So the correct option will be option D, okay? Notice the domain restriction and the equation here. And that is x over 2 plus 3. Consider the graph of the function defined by f from 0 to 2 pi. F of x is sine 2x. The square of the length of the line segment. Notice that we would like to find the square of the length. In Pythagoras, if I call it d, the distance, then I just need to find d squared. And it's x2 minus x1. So you have 3 pi over 4 minus pi over 4 whole thing squared. Plus f of 3 pi on 4 minus f of pi on 4. Bracket square. So actually, you don't have to take the square root of that expression. Well, basically, you say, all right, let's just go for f of x, again, is assigned to sine 2x, 2x. And we just get a 3 pi over 4 minus pi over 4, whole thing squared, plus f of 3 pi over 4 minus f of pi over 4, whole thing squared. And the answer is pi squared over 4 plus 4, which gives you option A. Pi squared over 4 plus 4, that is 16 over 4. And then we can look at the next question. Okay, next question says the number of pets X earned by each student in the large school is a random variable with the following discrete probability distribution. So the X value, like the number of pets, could be either 0, 1, 2, or 3. Now, if two students are selected at random, the probability that they own the same number of pets. So the same number for two students, like 0, 0, 1, 1, let's write a 1 probably, 2, 2, 3, 3. Notice that the result will be independent, okay? So let me just write them down properly. Okay, it was frozen. Yep, 0, 0, 1, 1, 2, 2, 3, 3. And now, 0, 0 is 0.5 squared. 1, 1, that probability is 0.25 squared. 0.2 squared, 0.05 squared. So basically, I could do 0.5, 0.25, 0.2, 0.005. Square everything and sum them up. 71 over 200, which is 0.355, okay? Yep, that is pretty much question 7. So we can move on and look at question 8. Question 8, we talk about the UV index Y for summer day in Melbourne, and it's illustrated in the graph below, where T is the number of hours after 6 a.m. The graph is most likely to be the graph of, okay, so what I'm trying to say is first, you identify the highest point and lowest point. And if you carefully align everything, like this is 7, this is 10, the amplitude may well be 5 here, 5 here. So this is like a reverted cosine graph. Like a cosine graph over one cycle looks like that. This is a positive cosine, and reflect, you get a negative cosine. So I would like to get some kind of negative cosine something. So that only retains option B or D. The next thing is we like to look at the period. This is one cycle or one period of the cosine graph. So the period equals to 40. And we can use 2 pi over n, and n is the coefficient in front of x. Therefore, n equals to 2 pi over 40, and n equals to pi over 7. So I would say option B is the most suitable answer. All right, question 9. If you take a look at a question 9, this is a typical question using integration by recognition. First of all, you have this relation, dx, x times e to the power kx is kx plus 1 e to the power kx. We'd like to get the integral here. Well, basically, we can write d dx x e kx equals to kx times ekx plus ekx. The next thing is we need to isolate, for example, this x ekx in this question. So let me just zoom in a little bit so you can see it better. Okay, and what I'm going to do is I'll first say x times ekx equals to 1 over k derivative x ekx minus ekx, okay? So if I do an integration both sides, that's integrating x ekx dx equals to 1 over k integral d dx. x ekx, subtracting ekx dx. Notice that this bit should be in a bracket, and we might want to put a plus c to the end. So next thing is, if I have 1 over k as the overall coefficient, then I'm able to get anti-deriving ddx gives me just x ekx. And if I'm anti-derive e to the power kx, I'll get a minus 1 over k e to the power kx at c. So this would indicate option D. Okay. Alternatively, if you use your CAS calculator, you might say, okay, just integrate this bit. X times exponential k times x dx equals to, let's try 1 over k times bracket x times exponential k times x minus integration. And then we say exponential k times x dx. And you can see the CAS calculator tells you it's true. It's because this expression at a c equals to that expression at a c. Okay, so that's question 9, option D. Then we can move on and look at the other questions. Okay, question 10. For the curve y equals to x squared minus 5, the tangent to the curve will be parallel to the line connecting the positive x-intercept and the y-intercept, where x equals to something. So if you draw a quick graph, like this one, I know I have a turning point of y-intercept at a 0, minus 5. And then this is minus root 5. This is root 5. So if I get, let's say, a line segment joining these two points, the gradient will be 0 take minus 5 divided by root 5 minus 0. That is just root 5. 5 divided by root 5. And then your dy dx is 2x and is equal to root 5. Therefore, your x equals to root 5 on 2. Okay, so option D is the correct answer. And the next question, we want to select a function to have a property fx minus fy equals to y minus x fxy. So the answer, I guess, it looks like option D. Because if you try option D, left-hand side is 1 over x minus 1 over y. And you can just combine them into one piece. Say x times y, you multiply y on the first fraction, multiply x on the next fraction. And this is y minus x times 1 over x times y, which is in the format y take x times f of x times y. So option D is the correct answer. Okay, next question, question 12. The graph of a function f is obtained from the graph of the function g with rule by reflection in the x-axis. So g of x will become minus g of x. So reflect that upside down. And then by a dilation factor of from the y-axis by a factor of half. From minus gx, you get a minus g of 2x. Okay? And that is something you obtain. For example, that is minus square root of 2 times 2x. That's 4x. Take 5. Okay? I believe option D will be the correct answer. Just be aware when you do the reflection in the x, you put a multiple, you put a -1 as a multiple in front of everything of the old function. And when you do a dilation factor over half, it's actually subbing in, let's say, 2x into the second function, right? Question 13 concerns an integral question. No CAS is needed and you don't know the ABCD values. So for example, the area of the shaded region is from, actually from 0, and then you get, okay, this bit. And also from here to here. The way I'm thinking about this question is I'll first look at the outer region. The outer region is under the graph f of x. So that is integral from 0 to the f of x dx. Then the inner part. For example, like this is B, this is A, this is C. I'm just knocking this part out. This is my g of x. So the inner part is A to C, g of x dx. Apparently, you want to use the larger integral to subtract the smaller integral, outer minus inner. Sometimes you don't see two functions with the bounded area between the same interval. So then you're not using, say, simply upper minus lower. You have to use, for example, the outer minus inner. Say this is outer, this is the inner, okay? So eventually when you work through the options, looks like 0 the fx dx minus a to c gx dx will be the correct answer. So option E is the desired one. Okay, we have 7 more questions to go. Let's move on. A rectangle is formed by using part of the coordinates axis and the point UV. UV is on the graph y equals to 4 minus x. So we can write UV explicitly like u comma 4 minus u squared. And if you notice, the rectangle has a height of v, width of u, area of u explicitly is u times 4 minus u squared. And here, because the rectangle is bound between the x, y axis and the curve, we will have 0 less than or equal to u less than or equal to 2. Okay, so that is the domain restriction. And we would like to find the maximum area of the rectangle. For example, we can use a of u is assigned to u times 4 minus u squared. And then we use f max, a of u, comma, u, comma, 0 to 2. And this is the u value. But notice this is the u value, not the maximum value itself. So you need to substitute the value u into the function. Say a of 2 root 3 on 3. So you get a 16 root 3 on 9, okay? This is u equals to 2 root 3 on 3. And the area max equals to area 2 root 3 on 3. That's 16 root 3 over 9. Option E is the correct answer. Okay? Question 15 concerns a box. It contains 6 red marbles and 4 blue marbles. So we have blue times 4. And red times 6. So these are the available items, okay? These are the available items. What I want to say here is now, if you look at the phrasing of the question, 2 marbles are drawn from the box without replacement. So each time you take a marble out, the total number will decrease by 1. And we would like to find a probability that they are the same color. If you did the counting method in year 11 for math method course, you probably recognize this is just like, okay, same color. We'd like to have a red, red, or blue, blue. You might want to use a tree diagram to illustrate this scenario, but my instinct is, okay, from 6 available red, I choose 2. And for the remaining 4 blue, I choose nothing. Divided by total 10, we choose 2. And then from the blue, we have a 4 choose 2 blue times 6 choose 0 divided by 10 choose 2. So this property holds if you are applying sampling without replacement. And you can use your CAS NCR 6,2 times NCR 4,0 plus NCR 4 choose 2 times NCR 6 choose 0 divided by NCR 10 choose 2. The answer is 7 over 15, okay? So that's very easy to solve. But again, if you don't use the hypergeometric distribution, you might want to say, okay, red, red. If the first one is red, it's 6 available out of 10. But if you take 1 out and don't put it back, you say the total is 1 less. And because you already taken out a red, it's 5/9. The other possibility is 4 out of 10 times 3 out of 9. Okay? Eventually, you get, let's say, 30 plus 12 divided by 90. So that is like 42 divided by 90. And then you get a 7 out of 50. Okay? Something along this line. So that's question 15. Okay, a few more questions to go. And if you look at a question 16, it's a normal distribution question. So I would like to get an X normally distributed with mean of 12 and a standard deviation of 0.25. The random variable Z has the standard normal distribution to get a probability greater than 12.5. That's X value. So the approach, you don't have to press the buttons. Just identify this is the mean value 12. As for X, standard deviation is 0.25. So that's 12.25. And that's 12.50. On the other side, you get a 11.75 and also 11.50. Okay, so that is like, okay, 2 standard deviation away from the mean value. If it's greater than 12.5, it's here or here. And you can draw a z-axis parallel to the x-axis. So in the middle, you always get a 0. 1 standard deviation away is 1 or -1 or -2. 2. So you either get probability of z greater than 2 or probability of z less than -2. The only available option is option E, probability z is greater than 2. Okay? And the other way you could verify this answer is use a numerical method like norm CDF, 12.5, infinity, 12, 0.25. So you get this answer, and you get a norm CDF, let's say 2 to infinity. If you don't fill out any mean and standard deviation, it will default to 0 and 1. Okay? So that gives you option, that confirms option E as the correct answer. Question 17, we have, let's say, inside a container, there are 1 million colored building blocks. It is known that 20% of the blocks are red. A sample of 16 blocks is taken from the container. For the sample of 16 blocks, p hat is a random variable of the distribution of the sample proportions of red blocks. Do not use normal approximation. Okay, if I call this red, it follows binomial distribution, n equals to 16, and p equals to 0.20. So in a 16 experiment, each one has a probability of success, like a probability of red is 0.2. Now, convert the p hat. P hat equals to r or x or whatever letter you call it, divided by 16. And therefore, r greater than or equal to 3 is in our statement here. So I would like to use binom CDF 16, 0.2, 3 to 16, and I get the desired number. Binom CDF 16, 0.2, 3 to 16. So the answer is like 0.6482. Option A. Right? Question 18. It's a continuous random variable x. It has a probability density function given by a quarter cosine half x from 3 pi to 5 pi. We would like to get a probability x less than a equal to √3 plus 2 over 4. So what you might do is now from the lowest value in the effective region, just ignore the 0, up to a quarter cosine of half x dx equals to √3 onto √3 plus 2 over 4. And you just need to solve that equation. Notice that its a value has to lie between 3 pi and 5 pi in the effective domain. So what we might do is integral, solve an integral 3 pi to a Oh, actually, I've defined A before, so let's use K here, a quarter cosine of x over 2 dx equals to fraction square root of 3 plus 2 divided by 4 for K, and it's between 3 pi less than K less than 5 pi. So you get a 14 pi over 3, okay? So that's option B. Yep, 2 more questions to go. Question 19 was considered to be a slightly more challenging question. But if you look at the discrete probability distribution for random variable x here, one thing is you need to recognize for any probability distribution, the sum of all probabilities will be 1. In that case, if you knock out the 0.2, the sum of these 4 cells in the probability cells will be 0.8. So what I'm trying to say is A plus 2B plus 2B plus 4B equals to 0.8. And therefore, you could say, all right, A equals to 0.8 minus 4B, okay? That's the first thing. So we say this is 0.8 minus 4B. The next thing is we would like to find the smallest and largest possible values of EX. So we need to get, let's say, EX equals to minus 1 times that, 0 times that, B times B, 2B times 2B, and 4 times 0.2 is 0.8. So we have minus 0.8 plus 4B plus 0B plus B squared plus 2B, 2B, 4B squared plus 0.8. So you can cancel out these 2 terms. And then you get 5B squared plus 4B, I suppose. The next thing is this B cannot be all real values because all individual probabilities should lie between 0 and 1. Therefore, you recognize these and get, for example, 0.8 minus 4B is larger than or equal to 0, less than or equal to 1. So you actually use your calculator, 0 less than or equal to that, B. And you will find, okay, it's from minus 1 over 20 to 1/5, but your B is a probability itself. So it has to lie between 0 and 1/5. Therefore, I'm going to use F max 5B squared plus 4B, comma B, comma 0 to 1/5. So the largest value occurs when B equals to 1/5. Then I can use F minimum, B equals to 0. So the smallest value of the expectation, EX, is 0. And 1/5 is 1, okay? So it's between 0 and 1. This was indeed a challenging question, okay? It has multiple layers to consider. Regarding question 20, you will have to use, let's say, this notation now. Txy equals to minus x, comma 3y plus 5. And under this transformation, f of x is transformed to g of x. So we would like to find a relation between f of x and g of x, and then evaluate this integral based on the given value here. So let's say, okay, f of x, if I use, let's say, a reflection in the y-axis, that will give me f of minus x. The next thing is, if you notice the 3 here, that is a dilation factor parallel to the y-axis. So multiply a 3 to f minus x, and then this is plus 5. So you get a plus 5 shifted by 5 units upward, okay? Reflection in y-axis, dilation factor 3 from x, or parallel to y, and then translate by 5 units up. So this resulting function is my g of x. Okay, so now my integration is minus 3 to 0, 3 lots of f minus x plus 5. dx. Notice that you have multiple options here. One option is to argue from the transformation aspect. The other option, okay, sorry, I have to go over both this time. I'm going to use the linear substitution. Say I make u equals to minus x. Just replace whatever function here with u. Then if I take the u dx, that is minus 1. Okay, I'm trying to find a relation between the infinitesimals. So dx equals to minus du, right? Next thing is if x is minus 3, my u is actually 3. When x is 0, my u value is 0. This method is called a linear substitution or change of variable method, which is part of the specialist math course. Anyway, the new integral can be written as u equals to 3 to u equals to 0, 3 lots of f of u plus 5. Notice that the last bit is not just du, it's minus 1 times du, okay? And you can pull out this minus 1, say minus 3 to 0, 3f of u plus 5 du, okay? And with minus 3 to 0, you can flip them over and get 0 to 3, 3fu plus 5 du. Okay, now you can split the integral like 3 lots of 0 to 3 fu du plus 5u evaluated between 0 to 3. Just anti-derive this bit. So the first part is 3 lot of 0 to 3 fu du. 0 to 3 fx dx is 5. So this bit is 5 times 3. And the other bit is 15. So eventually it's 15 plus 15. And that's equal to 30. So the final answer is E. Okay? All right, that is the end of the 20 multi-choice question. Hopefully you find it useful. And I will see you in the near future. Bye.